The reason why most pre-meds struggle with introductory physics courses or like physics on the MCAT is not because the physics is particularly complicated. After all, it's not quantum mechanics or like rocket science. It's relatively straightforward and intuitive stuff, but the way that many professors explain it is unintuitive. In this video, I'm going to explain torque to you like you've never learned it before. So this stick is balanced here because my fingers are at its center of gravity. Now, if I were to tie a rock on either side of the stick, then it'll rotate towards that side. And that is what torque is. It's nothing but the rotation due to force. Let's transition to the iPad to make this as clear as day. So this equation tells us the full story. We're not going to apply any sort of math here. We just want to understand it conceptually. So torque is going to depend on R, which is the distance between the force and the fulcrum, F, which is the force being applied, and sine theta, with theta being the angle between the force being applied and the stick or the beam. Notice here that torque is directly proportional with R and F, so that if you were to double R, then you double torque. If you were to multiply F by 2, then you're also multiplying torque by 2. All right, so what's happening over here? This is when the stick was balanced on my fingers. Nothing is hanging over here. As soon as I add this block over here, now suddenly it starts to rotate because the torque on the right is greater than the torque on the left because we added a force which created that torque. All right, so how do I rebalance this beam? Well, easy answer is to add another block of equal mass on the other side. So these are equal mass, equal distance from the fulcrum. So the torque on the left is going to equal the torque on the right. All right, so what if we were to double the mass of the block on the right? Well, if you double the mass of the block on the right, then it's as if you're doubling the force, which also means you're doubling torque. So now the torque on the right is greater than the torque on the left. Well, how do we rebalance it once again? We have two options. We can either double the mass of the block over here, or we can move the fulcrum so it's closer to the one on the right. This way, we doubled R, and therefore, the torque on the left and the torque on the right are going to be the same. If you understood this, then you're ready to tackle any sort of fulcrum or balanced beam question on the MCAT. The torques on the left will always equal the torques on the right. Even though here we have 1, 2, 3 torques, and here you have 1 and 2, these torques will necessarily be equal because the beam is balanced. Now, one note on this sine theta. So notice that when you have a block hanging down, the angle is always going to be 90 degrees, right? And then when you have a perpendicular force being applied, again, it's always 90 degrees. And here, you don't have to worry about it because the sine of 90 is going to be 1. And it's as if you're multiplying this whole expression by 1. Whereas when you're applying a force at an angle of, say, 30 degrees or 60 degrees, then that's when you need to consider sine theta. Like and follow if you found this video helpful, and let me know what questions you have in the comment section down below.